Hey Geometry, this is going to be our second video lesson and it's going to be on 10.5. If you didn't get a chance to see my video lesson tips from the 10.4 video, I wanted to show them to you one more time. Take notes just like you would in class, as if the teachers are up teaching in the board and you're writing everything down that we do. Have all your materials with you, including your calculator. One of the more important things is pause the video when you need to, so that you can catch up if I'm going too quickly. And if there's any questions that you have on the video, please put those in the comments in Google Classroom, or you can always email me or Mr. Filkins as well. All right, so we are going to be looking at section 10.5 notes for tangents, and that's on page 37 in your workbook. So if you open your workbook to page 37, that's where you will find today's notes. It's all about tangents. So first of all, what is a tangent? It's a line in the same plane as a circle that intersects the circle in only one point. It looks like this. So I've drawn a picture for the point of tangency. What is the point of tangency? Well, it's the exact single point where the line intersects the circle. So the point where the tangent and the circle meet. So I drew a circle and then I drew a line touching the circle in just one spot, and that's the point of tangency, okay? A line, ray, or segment that is tangent to two circles in the same plane is called a common tangent. So I drew a big circle and then I drew in my line there that's tangent to circle G. And then I drew a teeny tiny circle that's also tangent to the line. So these two circles have a common tangent. They have a tangent in common, okay? So hopefully all of that vocabulary makes sense. If you have any questions on it, once again, comment in Google Classroom, or you can email us. So using the figure to the right, draw the common tangents. If no common tangent exists, state no common tangent. So if I were to draw a tangent line to the circle on the outside, by the way, these are called concentric circles that we learned at the beginning of chapter 10. They appear to have the same center. If I were to try to draw a tangent on the outside, it might look something like that, okay? But notice it doesn't touch the circle on the inside. So if I were to try to draw a tangent to the inside circle, I could certainly make it tangent to the inside circle, but notice it's not tangent to the outside circle. It intersects the outside circle twice, and that means it's not a tangent. So there is no common tangent here. It's impossible for me to draw one line that's tangent to both circles. So I'm going to write no common tangent. Okay, let's move on to part B. I think this one's going to be a little easier to see. Same directions, draw the common tangents. I'm going to rotate my paper a little bit so it makes it a little easier for me to draw in that tangent since I'm left-handed here. If you can see, I'm trying to draw a line that just barely touches both circles. So I'm going to do the best that I can here to draw in a straight line that intersects the circle once here and once here. There's one of my common tangents. Now I have another one on the other side, right about there. There's the intersection for the small circle, there's the intersection for the big circle. And so there are my common tangents. Okay, moving on, go ahead and turn the page. All right, so for the next page, we have a theorem at the very top. This theorem says a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So I want you to fill in the word perpendicular and then draw this picture. If you have a line that is tangent, then you can draw in the radius, and that means it happens to be a perpendicular line. Okay, So moving on to example 2, they give us a triangle here on top of a circle. And it tells us that KL is the radius. So this here is the radius of the circle. It also tells us, or I'm sorry, it wants us to determine whether LM is tangent. So if I extended this, they want to know, is this really a tangent or does it possibly intersect the circle twice? It's hard to tell, okay? The only way to determine whether it's tangent or not is to use the previous theorem. If I can prove that this is a right triangle, then I would say yes, it is a tangent. If I cannot get that right angle there, then no, it's not a tangent. So notice we have a triangle here and they gave us all 3 sides of the triangle. So we are going to check to see if Pythagorean theorem works. If Pythagorean theorem works with all 3 sides, then we can put the right angle marking in there and then say, yes, it is tangent, okay? So the question that we're trying to answer here is, does a squared plus b squared equal c squared? Does the leg squared plus the leg squared equal the hypotenuse squared? Okay. If we were to type the left part into our calculator, we get 841. If we were to type the right part in the calculator, we also get 841. So that means that angle L is a right angle. So I can put the right angle marking there. And because it's a right angle, per the theorem up here, yes, LM is a tangent. Okay. All right, if you can, go ahead and pause the video here, and I want you to try part B on your own, and then unpause it and see if you get it right by following my work. It's the same directions here, just different letters. Determine whether YZ is a tangent. So once again, I've got a triangle here. I want to check to see if Pythagorean theorem works. So I'm going to say, does 14 squared plus 16 squared equal 21 squared? And you guys make sure that you're always putting the C value here. It's opposite the right angle that we're trying to prove is there, okay? So the longest side is always your C value. So is that true? If you type 14 squared plus 16 squared in the calculator, you get 452. If you type 21 squared in the calculator, you get 441. So I'm simply just going to put no, because those are not equal. That's not a right angle, which tells us that's not a tangent, okay? All right, moving on to example 3. This is a little more challenging and is going to require a lot of algebra work, so make sure you follow along very carefully and pause the video if you need to catch up at any point, okay? All right, in the figure, this time it's telling us this is definitely a tangent. That means that I can put my right angle marking there, okay? It tells me that it's tangent, and now it says find the value of x, okay? I'm going to use the same concept as the previous problem, and we're going to use Pythagorean theorem to find x. But the hypotenuse, we don't exactly know what that is because we don't know the radius of the circle. And the 16 is only from the edge of the circle to the point, the corner, the vertex of the triangle. So I need to come up with an expression for this entire side here. If from here to here is 16, and then from here to here is x, to get the whole thing, I would just have to add them together. So my expression is going to be x plus 16 for that entire side. Now I can use Pythagorean theorem. So a squared, I'll put as x squared for this leg over here, plus b squared, which is going to be the x plus 16 squared, but be careful, you want to square the entire side, not just the 16, so you have to put parentheses here. A squared plus b squared equals c squared. Oops, let me go backwards, I made a mistake. My b value, sorry guys, my b value is the 24 here. And then my c value is the x plus 16 squared. I almost made the mistake of not putting the c value in the right spot. Opposite my right angle is the x plus 16, so that should be my c value. So a squared plus b squared equals c squared. Now comes, I think, the more challenging part where we are challenged algebraically, and this is really where you want to make sure your Algebra 1 skills are fresh, okay? If I square 24, I get 576. Now, on the right-hand side, if I square that, I cannot distribute the 2 inside. Please do not do that. In Algebra 1, your teacher probably tried to drill that into your head. You cannot just distribute the 2 inside if there's a plus in the middle. We have to write it twice, and then we have to double distribute. Look at all this work in front of us. We have to double distribute. So let me do that. The left-hand side doesn't change, but now I have x times x, which is x squared, x times 16, which is 16x, and then I have to multiply the 16 by both pieces. 16 times x, and then 16 times 16, which is 256. Okay, now I can combine like terms here on the left-hand side, or sorry, on the right-hand side. So on the left, I have the same thing, but on the right, I have x squared plus 32x plus 256. Okay, I know it seems like I'm running out of room. I might go to the margin over here. Let's try to get the x squareds together, and we also have to get these constants together on one side. So I'm going to move this x squared over by subtracting it, and notice what happens. X squared minus x squared cancels, and it also cancels over here. That's a really, really good thing. So let me move to the margin now. We have 576 on the left, and on the right we have 32x plus 256. Okay, now to finish this off, I'm going to subtract the 256, and that gets me 320 equals 32x. Now I can divide by 32, and I get 10 equals x. Lots and lots of algebra work. So at this point, pause the video and try to do part B by using the same technique that we did in part A, and then go ahead and unpause it and see if you get it right. All right, so same work is given here. I am told that IK is the tangent, so I know that that's a right angle right there. And so to be able to find x, I'm going to use Pythagorean theorem. A squared plus b squared equals c squared. Now the c part, just like before, I don't know the c part because I don't know the radius, but I do know that from the vertex to the edge of the circle is 8, and then my radius is x. So if I want the whole thing, I'm going to add those pieces together, x plus 8. Okay, so now I can set up my Pythagorean theorem. So I have a squared, which is x squared, plus b squared, which is 16 squared, equals c squared, which is this whole piece, and you have to put that in parentheses to be able to square the whole thing, the entire side. Let's see, 16 squared is 256. And then over here, again, do not distribute the 2 into the parentheses. Write the x plus 8 twice, because that's what an exponent means, and then double distribute. All right, so we have x squared plus 256, and then let's see, x times x is x squared, x times 8 is 8x. Now we multiply the 8. 8 times x is 8x, 8 times 8 is 64. Now we can combine like terms. Okay, now I can move my x squared over, but just like before, all right, they canceled out. That makes our math a lot easier to deal with. Okay, now I only have one x term, so I'm going to subtract the 64 over to the other side, and I get 192. Then I can divide by 16. and I get x equals 12. Whew, lots and lots of algebra work. All right, if you're still confused, go back and try every single step again and really work out all the details, okay? All right, let's move on to the next page, page 39. This is a you try question, so I'd like you to pause it and see if you can try it without me, and then unpause it to see if you get it right. Determine if line AB is tangent to the circle. So we want to know, is this line a tangent? The only way to verify that is to see, is this a right angle right here? And the only way to check to see if that's a right angle is to check Pythagorean theorem. So we're going to check a squared plus b squared equals c squared. So notice opposite the right angle that I'm trying to prove is there, this is going to be my c value. So I've got, does 12 squared plus 16 squared equal 20 squared? Okay, if you type the left-hand side into the calculator, you get 400. If you type the right side into the calculator, you also get 400. So you can say angle A is a right angle. And so yes, AB is tangent. Okay. Moving on, we have another theorem to look at. I really like this one. It makes a lot of sense, and it makes it for really good, easy algebra problems. If two segments from the same exterior point are tangent to a circle, then they are congruent. In other words, here's a tangent, and they meet at the same point. If that happens, you know that these two pieces are equal to each other. So I put AB is congruent to CB. So fill in the blank, draw the picture, pause the video if you need to. All right, let's go to example 4. It tells me AC and BC are tangent. So this is tangent and this is tangent, and they intersect at point C. So based on the previous theorem, I know that this piece is congruent to this piece, and it wants me to find x. If these pieces are congruent, then I can set the algebra pieces equal to each other. So I have 3x plus 2 equals 4x minus 3. And then I can solve from here. I'm going to put the x's on one side, except I don't have to write the 1, right? I can just leave it as x and then add the 3, and I get 5 equals x. And they don't want me to plug it back in or anything. It just says find the value of x. All right, go ahead and pause the video and try B on your own, and then unpause it to see if you got it right. This is the same concept. We are told that MN is a tangent and MP is a tangent, and they meet at point M. So I know that those are congruent, so I can set them equal to each other. Let's get the constants on the right-hand side, the left-hand side, and then divide. And we get 7 equals x. All right, hopefully you found those a little easier than the other two algebra ones that we did. Okay, the last thing we're going to talk about is circumscribed polygons. Every side of the polygon is tangent to the circle. So here I have a triangle, and every side of the triangle is tangent to the circle. Here I have what looks like a square, but I'm not entirely sure if it's a square or if it's a form of a rectangle, but every single side of that quadrilateral touches the circle and is tangent. And then here I attempted to do a 5-sided shape. It's very, very challenging to do a 5-sided shape. The textbook does a much better job, but you can see that each side is tangent to my circle. So these are called circumscribed polygons, okay? So let's turn the page over and take a look and see what the examples are going to ask us to do. So for example 5, it says the round cookies are marketed in a triangular package to pique the customer's interest. If triangle QRS is circumscribed about T, find the perimeter of QRS. So they tell us that it's circumscribed, which means this is a tangent, this is a tangent, and this is a tangent, okay? So I'm actually going to use the previous theorem, this one here, knowing that these two pieces are equal to each other because they meet at an exterior common point. It's the same idea here. So let me show you what I mean. Here we have a tangent, here we have a tangent, and they both meet at point S. We are told that this section right here is 10 centimeters, so I know that this is also 10 centimeters, okay? Here's where it gets a little tricky. You don't know that this is 10. It's not that these are equal, it's that these are equal. If they meet at a common point, those two parts are equal. So over here, I can also say that these two parts are equal. The problem is I don't know what either one is yet, okay? So I have to go up here to point Q. This 2 centimeters, I'm not really sure which one it applies to, but it applies to one of them. So I know that this is 2, and I know that that little piece is 2, okay? Now what I do know is it gives me the whole piece from Q to R is 8. And if this is 2, then this must be 6 because I did 8 minus 2. 2 plus 6 gets me the whole thing, which is 8. So now I can say if this is 6, then over here this is 6 as well. So now it appears that I have all the pieces that I need to find the perimeter. So the entire side of this triangular shape is 12 because I know that that's 10 and 2. Over here, this entire side is 10 plus 6, which is 16. And then they already gave me the full side of this triangle, and that was 8. So to find the perimeter, I'm going to add the 12 plus the 16 plus the 8. And that gets me 36. And I believe we're in centimeters. Okay. Go ahead and pause the video and try the last question on your own and then unpause it to see if you got it right. All right, this one's very similar. Again, we're told that it's circumscribed, which means all of these are tangent lines, okay? And so because these two pieces meet at point A, I know that they're both 12. Because both of these pieces are tangent and they meet at point C, I know that this right here is 6. Now they give me the entire side of this triangle is 16. So if I do 16 minus 6, that tells me that this over here is 10. And if this is 10, then this is also 10 over here. Okay, so now if I add the sides together, I can get my full side. So 12 plus 6, that gets me 18. 12 plus 10, that gets me 22. And then they already gave me the full side for the other side of the triangle. So now to find the perimeter, I add 18 plus 22 plus 16, and that gets me 56 centimeters. Okay, that's the last question. Once again, to keep the video as short as possible, we're not going to do the summary in the video, but it would be good for you to try those two problems at the bottom of the page, and you can always email me if you want to know if you got them right or not. All right, I hope you guys took good notes and understand section 10.5 over tangents. Again, email me or comment in Google Classroom if you have any questions. And thanks for watching. I'll see you guys next time.